Hey everyone, welcome back to Infinite Math Help Squared. This video is going to briefly cover greatest common factor, otherwise known as GCF. So let's focus on this word first, what a factor is. Let's take a look at the equation 3 times 4 equals 12. 3 and 4 are called factors because they are what you multiply in order to get a product. Okay, now that we know what a factor is, what do they mean by greatest common factor? Well, this one we all recognize, right? If something is in common, it's the same or similar. And greatest, we're all familiar with also because it is the biggest compared to others. So let's take a look at a quick example. What if we had two numbers, 8 and 14, and someone says to us, hey, what's the greatest common factor? Because that's what we would be talking about at lunchtime, right? Greatest common factors? Okay, just kidding. So, for 8, what numbers do I multiply to get 8? Well, I can multiply 1 times 8, and I can multiply 2 times 4. All right, and we're talking about whole number multiplication, whole factors, okay? How about 14? I can multiply 1 by 14. I can multiply 2 by 7. And that's going to cover it. So now the question becomes when you compare the list. When you compare the list, what is the greatest number that they actually have in common? Well, 1 they have in common, but it's not the greatest, okay? Obviously, it's 2. There's nothing else here that they have in common. So what is the GCF of 8 and 14? It's 2. And that's how that works. Okay, let's look at something a little bit more complicated. And then that'll be our last example. What if we had, because it doesn't have to be 2 numbers. It can actually be more than 1 number. And this is going to help you in higher level mathematics when you have to start solving more complicated equations. Okay, let's take a look at three numbers. We're going to look at the numbers 30, 48, and 60. Okay, now what are the numbers that I would have to multiply by to get to 30? Always 1 and the number, right? There is 2 times 15. There is 3 times 10. And you see how I'm closing in and these numbers are getting closer together? That's not a coincidence. I spaced them out to pair up like this because it helps me understand where I should stop. Because now, what do I have left between 3 and 10? 4, 5, 6, 7, 8, 9. Well, I know that 5 times 6 is also 30. And now my numbers have closed in so that they're next to each other and I can stop. How about 1 and 48? 2 and 24. I believe it's 3 and 16. 4 and 12. And once again, you can see how they're closing in on each other. And now I only have 5, 6, 7, 8, 9, 10, 11, right? And I know that in that set, that 6 times 8 is 48. Multiplication tables will help you here, but the problem with multiplication tables is that sometimes the numbers are really big and your multiplication table will only go so far. However, I will link a multiplication table in here for you in the description, no problem. Okay, last one, 60. We're going to go with 1 and 60, 2 and 30, 3 and 20. 4, I believe 4 works, right? Isn't that 15? Okay, 4 and 15. I'm running out of space. 5 times 12. Oof. And I still have 6 times 10 to squeeze in here somehow. And again, you see how they closed in so that there's only 7, 8, and 9 left, but nothing 7, 8, and 9 will go into 60 evenly. Okay, let's examine these lists very carefully. I notice that 30 appears in 30 and it appears in 60, but unfortunately it doesn't appear in 48. How about 15? 15 will appear in 30 and 60, but it does not appear in 48. Okay, let's go here to 10. 10 appears in 30 and 60, but not in 48. How about 6? I think we have a winner because I see 6 in 30. I see it in 48. And I see it in 60. So, if my work here is accurate, that would mean that the GCF of 30, 48, and 60 is 6, because that is the greatest number that they have in common. It is not the only one they have in common, because you can see here that there is a 3 that repeats, 2, obviously 1 is always there, but it's not the greatest. The greatest factor that they have in common is 6. Okay, guys, till next time.